All right. Moving forward, we'll start talking about Charles's gas law. So what consistency would there be between Boyle's and Charles's gas law? What variable would they have in common, would you guess? Not pressure. Volume. That's correct. Okay, and then... So as we know, if we're dealing with this, volume 1 times pressure 1 equals your new set of conditions. Okay, and then we're dealing with Charles's gas law. Okay, and what is it that you can do to possibly help yourself out? What type of relationships do these have with each other? One is an inverse relationship. The other one is
an X-verse.
Direct. I think that's a better way of looking at it. Okay. So when it comes to Charles's gas law, if the temperature's going up, what's the volume going to do?
Inverse, outverse.
Volume also is going to go up. So that's a direct correlation or relationship. And when it comes to pressure, what does volume usually measured in? You got 3 variables that you had on your paper.
Kilopascals. Millimeters of mercury.
Millimeter, no. Milliliters, liters, and then cubic centimeters. Cubic centimeters and milliliters are the same thing. And then when it comes to pressure, there is your 3 types. Kilopascals, millimeters of mercury. And so if you eat that, as you keep yourself away.
There's so much sugar in it, you know?
Yeah. Or you keep other people away.
Not true.
Okay.
Kind of satisfying, though.
We're all doctors,
Okay.
is what he said.
Yeah.
Oh, yeah.
Yeah. Is that true?
I just told Sora she become a doctor.
Who should become one?
Sora.
Oh.
I'm not.
Is that true?
No way.
Not sure.
Do you have those types of aspirations when you go home? No? Oh, okay. All right.
Just take daddy's shoes.
Anyway, okay. So then when it comes to volume for Charles's gas law, it's still the same, but we want temperatures to be measured in degrees Kelvin, okay? So when it comes to pressure, if it was given in kilopascals, you divide by 101.325. It was given in millimeters of mercury, you divide by 750. And then that would change them to what?
Atoms.
No. Atmosphere. Well, atoms. I understand what you mean, but yes, atmospheres. Okay. But when it comes to that of Charles's gas law, again, those temperatures are supposed to be in degrees Kelvin. It's probably given to you in a word problem measured in degrees centigrade. So to convert that to degrees Kelvin, you just add the constant 273, and that's all you do. So in this case, if we could just say, that's not right.
No idea. Some sandals. And Coexol. Yes. My mom just sent me that. I was gonna, does she know who Coexol is? No, it was John and Dan versus my brothers, and they whooped my brothers so bad.
John, well,
2-on-2.
really? I suppose your dad has the height.
Just one of my brothers, Dan though,
The dad you carried.
his strides are so bad. Dan got carried, but I mean, he does kind of have a wet number.
Okay, so what presumption could you make with that? If at ground level, this hot air balloon has 3,000 liters of air in it, it's at -3 degrees centigrade. What is the temperature when the volume decreased to 1,780 degrees? So if the volume is going down, what would you presume the temperature is going to do as well? It's also going to go down. So we just have one conversion to make. We just chose a negative temperature here because rather than adding 273, you just subtract 3 from 273. And if my math is correct, I would say that's 270 degrees Kelvin. Okay.
Do you have to add 273 or subtract it?
Add it. But
You add it, but it's a negative number.
Yeah.
I mean, this is a negative number. That's what I mean. So you're actually subtracting that. And then just like that of your Boyle's Law paper, we have your initial conditions. It's saying what's the volume going, or excuse me, the temperature going to be at a specific altitude. Really don't know for sure. Okay, but the volume 2 was 1780 liters. This one was 3,000 liters, and the temperature was 270 degrees Kelvin. And again, if this was perhaps a positive value of 3, well, then you have 276 degrees Kelvin. But since we're just going to say it's cold outside, but you wouldn't see any balloons outside on a day like today. Of course, I don't know what the temperature would be in degrees Kelvin, but okay. So what happens is if this was 3 degrees centigrade, you would add 3 and get 276 if there was a positive value.
So for any value,
Okay. So what constant do we add to degrees centigrade to get degrees Kelvin? 273. Okay? So if that was the case, okay, and if that was a positive value, okay, you'd have 276 degrees Kelvin. But how the problem had began was saying it's a negative value, okay, temperature. So you're not adding that unless you want to do, you change your signs and then you can do that. I mean, you're doing the same thing. But then now that's not 276, but rather 270, okay? When you got that negative sign in there, then you just subtract that. Just keeping it simpler for yourself. Okay, does left side, are we on the bus then? Okay, middle.
will we ever have like Fahrenheit or?
How do you transfer Fahrenheit to Celsius?
like 3, 2, 1, and then
Oh, we should learn how to do that because that's on ACT.
Oh, it is.
3, 2 is
Okay.
zero.
We can do that in just a moment. That's a good question. It's looking in the future, maybe on your final. And then right side. Okay, so what known values do we know between Fahrenheit and Celsius? You can go by water's freezing point, or you can go by water's boiling point. Which one would you want to pick? Okay, so if we were, we'll come back to this in just a moment. If we had 0 degrees centigrade, oh, I'm going under the presumption, which one do you want to start with? Fahrenheit or Celsius?
Fahrenheit.
Okay, you want to start with Fahrenheit. Okay, so therefore we know what is 32 degrees Fahrenheit going to be on the Celsius scale?
0.
It's going to be 0. So mathematically, we can show that. Okay? There's a formula that you can use by taking it times 5/9 or 9/5 or something to that effect. To me, this has always been a lot easier. There's 3 steps. Okay? So can we erase this here? I'm thinking if you wanted to write this problem down, you would have done so. And we've got the important information there. Okay, so changing that then in step 1, all you're doing is adding 40. Okay, so in step 1, you take your whatever degrees you have, you're adding 40. So that's going to equal a specific number, in this case 72. Then in step 2, okay, since you're going from Fahrenheit to Celsius, you're going to divide by a constant of 1.8. Okay, so now we are going to take 72, divide that by 1.8. That's going to give us a specific number, and then in step 3, you just do the opposite of what you did in step 1. So it's probably no surprise that when you divide these two, you're probably going to get 40. Okay, so 72 divided by 1.8 equals 40. And then just the opposite of what you did in step 1, this answer minus 40 equals 0. So you can use that to prove that on known temperature scales, you can show how this actually works.
Do you like cross multiply?
Yeah, cross multiply.
32 is 0 as 71 is X.
Yeah, you could definitely.
Okay, repeat that again, sorry.
Like say it said what is 71 degrees Fahrenheit in Celsius? Can you do it?
Oh, okay, yeah. So what do we know that water boils at on the Celsius scale? 100. So we know that on the Fahrenheit scale, it is 212. So you just want to see just the opposite. Okay. So therefore, we're just doing the exact opposite. We're going to do 100 degrees Celsius and change that to degrees Fahrenheit. The only aspect that is different is, like you, I think, pointed out already, is rather than dividing by 1.8, you're going to multiply. But in this case, we're starting with 100. Okay, so that gives us 140. 140 times 1.8, what do we get? Probably 252, right? So 252. And then taking that 252 minus 40 gives you that 212. Okay. I don't know if you'd ever seen a different type of conversion where you get, sometimes I've seen periodicals use 9/5 or 5/9 depending upon which way you're doing it. To me, this just seems, it's a lot easier. At least I think so. The only, what you got to keep separate is, okay, we do this in A&P a lot. So rest of you, sorry. It's just something stupid that I tell myself all the time, so I know which way we're going. Okay? So in this case, if you're ending in Celsius, I always think of compact discs, which was big in my time when I was in college. CDs are compact discs. So why would we say CDs? Well, here's your C, and then what are you doing in that intermediate step here? You're dividing. So that's why we say CD. Then if we're doing this step, Fahrenheit to Celsius, then I just think of FM radio. If it's FM radio, then you are multiplying then instead of dividing. It's stupid, I know, but something that's stupid you won't forget. Like today I know it's a palindrome, today's date is a palindrome, but it's also something like an alendrome or something like that. First of all, do you know what a palindrome is? It's a number or a word that's spelled the same both ways. So then this anadrome, whatever that is, it's the same number upside down as it is right side up. Which makes sense because today's date is what? Second month, 22nd day, 22nd year of year 2000. So 2, 2, 2, 2, 2. That's really funny. 2, 2, 2, 2. That's really funny. 2, 2, 2, 2, 2, 2, 2.
0.
No. I don't know. All right. Can we close the books on this here?
Yes.
Okay. So did you have to guess on the ACT then, or you just know that it's on there?
I think I did it like 0 is to 32 as something
Oh,
like
I
that.
suppose you could do that, I guess. But
No, it's more like 2 I think that's what I did.
okay. All right. So getting back to
Easier way.
our original problem then, once you have this, just do what the formula tells you to do, which our first temperature, 270. Okay? Times our second volume, which was 1780, equals our first volume, 3000. Oh, yeah. Okay. And then our unknown, which was T2 then. Okay? So 270 times 1780.
When you go TI. Oh.
Okay? Then in this case, we get temperature 2 equals 160.20 degrees Kelvin. Okay, so in this case, the volume had gone down, so then this number should be smaller than 270, and it is. Okay. All right. Left side. We are. Okay. And then middle. Good. And then right side. Okay. I just don't have it wrote down yet. I can tell you what it is that we're doing. So then, yes, Friday we'll do, it's a Charles gas law experiment. So kind of related to this, of course. Okay. So I'll hand this out, and then the rest of the time will be yours. All right. Catch up to you next time.